Hey everyone, this is Dan Jones. I wanted to show you a little bit about the Delta printer that I've been designing and building. It's not quite running completely yet, but I hope to have that working soon. This is just going to show what I've done so far. The Delta printer is pretty simple actually. There's 3 columns. Mechanically they're all the same. Each of the columns just has a little slider that moves up and down. This is one of the sliders here. You can see the belt attaches to the slider and pulls it up and down. That occurs for each of the towers, and the effector right here in the center moves back and forth, left, up and down, and also in the Z direction. So first of all, this printer is just about 40 inches tall, plus the motors. The motors are NEMA 17, the standard 3D printer motors. I've got a 16-tooth gear on it driving the belt, and let's see, down here at the bottom is the pulley that the belt rides on, and this is how I tighten the belt. I loosen this screw right here and move it up and down the path in the center. This aluminum extrusion was bought from Inventables out of Chicago in the United States. It's great stuff. They sell quite a few hardware pieces that go with it, including this the roller that goes on the sliders. These have a eccentric cam on 2 of the screws here, so that I could twist the eccentric cam and tighten or loosen the rollers on the aluminum extrusion. The arms of the Delta printer are made out of aluminum that I got from the hardware store. Inside here I have Teflon tubing with a magnet inside of it that hold it to the magnetic ball that's on each of the sliders. The same thing is true for the effector. They use the ball system as well, and it holds quite well, but I'm a little bit worried about the strength of the Teflon. Right here it seems to have bend a little bit when it's under strain, so I may move to a different solution for that. The plastic for this whole thing, both the bottom piece and the top piece, are the exact same pattern. So when I cut that out with my CNC router, I just have to cut one piece twice. You'll notice these corner braces here. It's just a flat piece of plastic that's bent twice. That plastic right here is this piece right here that's been cut a little bit more, so there's not a whole lot of waste when cutting this out. The plastic was bent. It's bent here, here, and here. I went and bought a small metal bending brake for sheet metal and cut a slit or a groove in the bottom area here for each of the bends, and then heated it up with a torch and made the bend with the metal brake. That seems to have worked quite well. I'm happy with the results. They seem fairly accurate, and maybe in the future I'll play with aluminum and see if I can get it to go in better. But anyway, it works good. I wanted to make sure that the screws that hold the belt were in the center, so that I don't get any action this way. So that means that the belt itself had to be sort of off-center a little bit so that it can pull up and down on these 2 points here. The end stop is just a normally open switch that I got from DigiKey, and it's screwed to a piece of plastic and then held in place with a screw on the aluminum extrusion. That allows the homing action to find the center of the machine when it runs a print. Now, I want to give a shout out to Elias Bakken in Norway, who has been instrumental in getting me all the help I need to get this working. He makes the Replicape, which is running on top of a BeagleBone Black, and this is the A4 version. It's the stepper motor driver here. It's got the limit switches over here, the network and serial interface. When I hook up my extruder, it'll go over in those connections there. So far, I'm really quite pleased with the Replicape. It's doing everything I ask it to do, and the software for it is a little bit tricky, but in the same right, it gives the user quite a bit of power, and we can do whatever we want to with it. It's all open source, and I really do like it. The power supply is just a simple 12 volt 30 amp power supply I got off eBay. Nothing too special about it. I wanted to make sure that this whole machine ran off of 12 volts, so I didn't have to play with different power supplies. The extruder for it is from See-Me CNC. It's this guy here, so I'll get that installed soon. I'm really excited about how clean of a setup this is and how well designed it is. It'll use a Bowden tube to the hot end, which goes in the center of the effector. This is my second 3D printer. I've never made or designed or even seen a Delta before, but thanks to YouTube, this has gone quite well. See-Me CNC has also supplied the glass, the borosilicate glass at the bottom, which is where I plan on do the printing. So right now I've got Octoprint hooked up. It is a web-based application that allows you to print things. So I'm going to go ahead and hit the print. The first thing that we're going to see is that it's going to home itself. So each of these sliders are going to go up to the top and hit the switches, and then the whole thing is going to go back down to the 0 position, and then it's going to start the print. So I'm going to hit the button. Right now it's just moving around like it's printing a small cube, so it's doing the perimeters. But you'll notice how the left, right, backwards, and forwards movements are accomplished. Each of the sliders moves up and down and triangulates the right position in Cartesian coordinates. So all that math is done in real time by the BeagleBone Black, and it's really quite fun to watch. Alright, I hope I've explained enough about my new machine. Hope to get it working and actually printing something here soon. Please, if you have any questions, let me know. Thank you very much for watching.